Counting rules. The basic counting rule. Suppose that our actions are to be performed in a definite order. Further, suppose that there are M1 possibilities for the first action, and that corresponding to each of these possibilities are M2 possibilities for the second action, and so on. Then there are M1 times M2 times up to MR possibilities altogether for the R actions. Example. The owner of a stereo store wants to advertise that he has many different sound systems in stock. The store carries 6 different CD players, 7 different receivers, and 9 different speakers. A sound system consists of one of each. How many different sound systems can he advertise? The counting principle tells us that we can just multiply the CD players times the receivers times the speakers. 6 times 7 times 9, which is 378. So he can advertise 378 sound systems. Factorials. The product of the first k positive integers, counting numbers, is called k factorial and is denoted k exclamation point. In symbols, k exclamation point equals k times k minus 1, and so on, times 2 times 1. We also define 0 factorial equal to 1. Example, evaluate the expression 5 factorial. So what the factorial means is that I'm going to start with 5 and count down till I get to 1, and I'm going to multiply all those numbers. So 5 factorial equals 5 times 4 times 3 times 2 times 1, which is 120. Permutations rule. The number of possible permutations of R objects from a collection of N objects given by the formula NPR equals N factorial divided by N minus R parentheses factorial, or the permutation of N choose R. Example, evaluate the expression permutation of 8 choose 4. Looking at our formula, we know that N is 8 and R is 4. Substituting, we have 8 factorial divided by 8 minus 4 factorial. There are 2 different ways that we can find this answer. Going to our calculator, we start by typing 8, then we go to our math menu, over to probability, go down to the exclamation point, enter. So we have 8 factorial, divide, parenthesis, 8 minus 4, close parenthesis, go to math, over to probability, down to 4, enter, enter again, and we get 1,680. There is a second way to find the permutation using our calculator. I type in N, which in this case is 8, go to the math menu, over to probability, but this time I want the second one, NPR. Then I type in the 4, enter, and I get the same answer, 1,680. For some of you, it may not look like that. You may type in your 8, then you go to your math menu, over to probability. You choose the second one, which is NPR, and you actually see the NPR. Then you type your 4, and you still get the 1,680. It's just 2 different appearances, but it does the same thing. Permutation of 8 choose 4. Which is 1,680. The special permutations rule. The number of possible permutations of n objects among themselves is n factorial. What this is saying is if I have 10 books and I choose all 10, instead of doing a permutation of 10 choose 10, I can just find 10 factorial. Example. A musician plans to perform 7 selections. In how many ways can she arrange the musical selections? One way to set this problem up is to find a permutation of 7 choose 7. Using the formula, that gives us 7 factorial divided by 7 minus 7 in parentheses factorial, which is the same as 7 factorial divided by 0, which takes us to 7 factorial. Using the special permutations rule, we could have just started with the 7 factorial. Either way, we get 5040. So we have 5040 ways to arrange the musical selections. Combinations rule. The number of possible combinations of R objects from a collection of N objects is given by the formula NCR equals N factorial divided by R factorial times N minus R factorial. The main difference between a combination and a permutation is that when you use a permutation, order matters. When you use a combination, order doesn't matter. Number of possible samples. The number of possible permutations of size n from a population of n is NCN. The capital N refers to a population, whereas the lowercase n refers to a sample. So when we talk about the possible sample size, we have capital N combination lowercase n, meaning if I have a population of size n, I can choose a sample of size lowercase n, and that will give me my total sample size. Example. Evaluate the expression 8C4, or a combination of 8 choose 4. Using our formula, 8 is n and 4 is r, which gives us 8 factorial over 4 factorial times 8 minus 4 factorial. The thing that you need to be careful about when you type in this formula is your denominator needs to be in parentheses, because you need to do the multiplication in the denominator before you do the division with the numerator. Going to our calculator, I'll start with 8 factorial. So 8, I go to the math menu, over to probability. I'm going to choose 4, which is our factorial, divided by, open parentheses, 4 factorial. So I'll go to the math menu, over to probability, choose 4, which is my factorial, times 8 minus 4 factorial. So to get my factorial, I go to math, over to probability, choose number 4, close the parentheses for my denominator, enter, and that gives me 70. This isn't the only way that I can find a combination using our calculator. As you may have noticed when you were in the math menu, we also have the combination. So I type 8, go to math, over to probability, and this time we want number 3, NCR. Enter. We type in 4, enter, and I get 70. First, I'd like for you to notice the difference between the answer for our permutation and our combination. With the permutation, since order matters, we have a much larger number than we do with the combination when order doesn't matter. Permutation of 8 choose 4 is equal to 1,680, while a combination of 8 choose 4 is equal to 70. Now let's say this isn't the view that you have on your calculator. So I type my 8, I go to the math menu, over to probability, I choose 3, and it says NCR between my 8 and my 4. Enter, I still get 70. Combination of 8 choose 4 is 70. Example: there are 10 members on a board of directors. If they must elect a chairperson, a secretary, and a treasurer, how many different slates of candidates are possible? For this example, it's important who's the chairperson versus who's the secretary versus who's the treasurer. Because of that, we want to use a permutation. I have 10 people to choose from, which is n, and 3 candidates. So my permutation is 10 choose 3. Substituting into the formula, I have 10 factorial over 10 minus 3 factorial. Going to my calculator, I type in 10, go to the math menu, over to probability. I'm going to use NPR. I type in 3. If I ever need to get out of the R position, I use my right arrow button, and that will make my cursor larger, and then I can multiply or divide by something else. Enter, and I get 720. So there are 720 slates of different candidates possible. Example: there are 9 members on a board of directors. If they must form a subcommittee of 4 members, how many different subcommittees are possible? This time, we're just having a subcommittee. It doesn't matter who's first, second, third, or fourth, so I can use a combination. N is 9, R is 4. I could substitute into my formula 9 factorial divided by 4 factorial times 9 minus 4 factorial. Going to our calculator, I can use the NCR function on my calculator. I start with 9, math, over to probability. I want number 3. Then I type my other number, 4. I can press my right arrow key to get out of that if I want. Enter, and I get 126. So 126 different subcommittees are possible. To recap counting rules, the basic counting rule tells us that we can just multiply together our different options to get our total possibilities. A factorial is represented by an exclamation point. You're to start with that number and go down to 1 and multiply all those numbers together. So 4 factorial is 4 times 3 times 2 times 1. The permutation rule is when order is important. It is represented by NPR and equals n factorial over n minus r factorial. When we have n items, choosing r at a time. The combinations rule is when order is not important, represented by NCR. Our formula equals n factorial divided by r factorial times n minus r factorial. When we have a combination of n choose r.